Welcome to this brief Infinera training module that will guide you through an overview of the CHM1 and CHM2 Muxponder options for the Groove G30 chassis. In a simple Groove G30 network, we supply a point-to-point connection which includes Muxponding. Muxponders take client signals on one side and have the ability to encapsulate, encrypt, multiplex and channelize. Multiplexing is a method of combining multiple client signals onto a single line-side fibre. In this example, we have a single client sending 100 gigabits per second. The line side is running at 200 gigabits per second. This means that only half of the available capacity is being utilised. If we have a second 100 gigabits per second client signal, this could also be placed on the line side using the available capacity. When sending data over a fibre, we can wrap the signal into a predefined structure such as OTU4. The main advantage of using OTU4 is that the forward error correction, known as FEC, is applied to the signal. At the far end, the receiving Groove G30 can check the FEC, correct any received errors, and then pass the data out on the client port. In practice, this means we can extend the span range between two sites. This is because errors that are caused by the system working at the edge of its span range can be corrected. This is often known as coding gain. Many customers require encryption of data before it leaves their site. The Groove G30 can apply encryption before the signal is passed onto the line-side fibre. The encryption key is only known at the two terminating sites. At the far end, the Groove G30 can apply the decoding key and pass the unencrypted data out at the client side. At the higher level, we can use an OMD 96 to multiplex up to 96 channels onto a single fibre. The output of a Muxponder has to be using the same channel as the port on the OMD 96. The CHM1 offers pluggable optics that allow you to select the correct channel. We call this channelization. This block diagram shows 4 client signals on ports 3, 4, 5 and 6 being multiplexed onto 2 line-side channels, which are ports 1 and 2. In this example, we can see two 100 gigabits per second client signals going into ports 3 and 4. The CHM1 multiplexes them together onto a single data stream. In addition to this, it could wrap them into OTU format so that forward error correction is added. Finally, you can select the appropriate transceiver on the line port to ensure the data stream is on the correct channel. In this example, ports 5, 6 and 2 are not used at the moment. The CHM1 is a single sled module, so requires just one slot in a Groove G30 chassis. In the example we just used, we would need to fit client-facing transceivers in ports 3 and 4 and the channelized transceiver in port 1. This is a list of the available transceivers that can be plugged into the client side of a CHM1. You do not need to remember this list, but generally the same transceiver is used on the client device. You will also notice that the QSFP28 offers an OTU4 option. Although the CHM1 offers OTU encapsulation, some service providers will deliver their client signal already wrapped up in this format. The CHM1 is flexible enough to accept a wrapped signal from the client, or alternatively, add OTU4 encapsulation to an unwrapped signal before passing onto the line side. We can also offer different transceivers on the line side. This is where channelization is applied. For example, you can select the channel that the CFP2 is transmitting on. This will determine which channel is used and which port you connect to on the optical DWDM multiplexing module. We also have a CHM1G single sled module, where the G stands for green. The CHM1G is very similar to the CHM1 with exactly the same physical dimensions. The module has been developed more recently and uses 40% less power than the CHM1 and also offers service providers the added benefit of encryption, the ability to add security to a signal being passed onto the line side. The CHM1 and CHM1G has been designed to work with advanced modulations such as DP-QAM, where we can multiplex more than 2 client signals onto a single channel. In this example, you can see that the client signals on ports 3, 4 and 5 are all multiplexed onto a 300 gigabits per second channel on a single line-side fibre. The CHM2 is a double sled module and therefore requires 2 of the 4 slots in a Groove G30 chassis. The CHM2 is more flexible than the CHM1 because it offers a variety of client rates including 100 gigabits per second and multiples of 10 and 40 gigabits per second or fibre channel rates. The line side remains the same. This is a list of available client and line optic ports. While there is no need to remember every option, you should appreciate the flexibility of this as a Muxponder, particularly when considering working with other open line systems. All examples so far have been in one direction to simplify the concept. However, you should appreciate the Groove G30 is bidirectional, meaning it works in both directions. By now you should understand that a CHM1 Muxponder is a single width sled module used in a solution to encapsulate, encrypt, multiplex and channelize the client signals. When we talk about CHM1G, you'll appreciate the G stands for green as it uses less power than the standard CHM1 and also offers encryption. Finally, you should understand that the CHM2 is a double width sled and offers a variety of client rates including 100 gigabits per second and multiples of 10 and 40 gigabits per second or fibre channel rates. Well done on completing this module. It will be marked as complete but will continue to be available to you on our learning management system.